Okay, so for question number 28, we have to find the particular solution of the given differential equation. So given differential equation is it's dy upon dx plus secant square x into y is equal to tan x into secant square x. Okay, and this is our equation, and it seems to be of the form dy by dx plus py is equal to q, and if we compare these two equations, it gives us e is equal to secant square x and q is equal to tan x into secant square x. And we know that the general solution for this form is integrating factor. We have to find the integrating factor first. So integrating factor is equal to e raised power integration of p into dx, which is integration of p is secant square x into dx, and integration of secant square is tan x, so it's e raised power tan x. Okay, now general solution, we have to find the particular solution. So let's first of all, let's write down the general solution for such equation, and then we will evaluate for the particular solution, that is a find value of c. So general solution is given by y into integrating factor is equal to integration of q into integrating factors integration. So integrating factor is e raised power tan x, integration q is tan x into secant square x, integrating factor is e raised power tan x. This whole has to be integrated. Okay, so let's focus on this integration. And in this case, for this, we can take tan x, we can resubstitute the value. So let's say it's y into e raised power tan x is equal to I. So this is I. And let's try to integrate it. So I is equal to integration of this is tan x into secant square x into e raised power tan x into dx. And let's substitute and we know that the position tan is it's secant square x into dx is equal to dt. So secant square x into dx, it becomes dt, this is t, this is t, and finally our integral I is equal to integration of this is t into e raised power t into dt. Okay, fine. For this, we are going to use integration by parts, and our first function, this is our first function, this is our second function, and using integration by parts, we get. So if we use integration by parts, which says it's the first function into integration of second minus integration of differentiation of first into integration of second, the whole has to be differentiated with integrated with respect to t. So it's t integration of e raised power t is e raised power t integration of t. So one integration of e raised power t is t. So this is t into e raised power t minus e raised power t. And if we substitute the values, this is tan x into e raised power tan x into e raised power tan x, and this is e raised power tan x is common, so this is tan x minus 1. Let's resubstitute its value in this equation. So our general solution is y into e raised power tan x is equal to e raised power tan x into tan x minus 1 plus c. And it's given for to find the particular solution, we should know the value of c, and it's given that when y is equal to 0, x is equal to 0. So it's given when y is equal to 0, x is equal to 0. So this becomes 0 is equal to e raised power tan 0 into tan 0 minus 1 plus c, which gives us this is e raised power 0. and then 0 is 0, 0 minus 1 plus c, and this is e raised power 0 is 1, so this is negative 1 plus c, so that means c is equal to 1, and which gives us our particular solution is y into e raised power 10x is equal to e raised power 10x into 10x minus 1 plus 1. So we have substituted the value of c, and now y is equal to e raised power 10x minus 1 upon e raised power 10x plus 1 upon e raised power 10x. So this gets cancelled, and it is y is equal to 10x minus 1 plus e raised power negative 10x. And this is our particular solution for the given differential equation. Let's move on to the next question.